Okay, let's look at example 14.7. Here we have a man pushing a crate. The crate is 50 kilograms. Has a force of 150 newtons. Notice that it is at an angle. Okay? So what do we want to do here? We want to determine the power supplied by the man. Okay? The power supplied by the man at a certain time. Okay, and then there's friction with a certain kinetic coefficient of friction. Initially the crate is at rest. Okay, so the question is, determine the power supplied by the man. So immediately when I see what the question is, I say, well, I know that power is F dot V. Force times velocity, but it's true that it's force times velocity, but technically it's the force vector dot the velocity vector. And the reason why this is important is because power is only the component. Remember, this is the dot product. It's only the component of the force in the direction of the velocity that we want to look at. Right? That's what the dot product is saying. We're saying, there's my force vector, my velocity vector is in that direction, and there's an angle there. So F dot V would be then the magnitude of F times the magnitude of V times the cos of the angle. All we're saying is, it is the component of the force in the direction of the velocity times the velocity. Okay. Alright. But nevertheless, that is where we're headed. Okay, so power, we need force information and velocity information. Okay? So force information, we always jump to our free body diagram. We have weight acting down, normal force acting up, and because the crate is going to move in this direction, we have an opposing frictional force, and we've got that applied force by the man acting at this angle. Okay, 5, 4, 3. All right. So, what are we trying to do? We know what the force is. Well, we sort of know what the force is. We'll get back to that in a minute. The force is this 150 Newton, but why would I not put this force in here? Right? We're looking at the power supplied by the man. The man is applying 150 Newton, but why would I not put it over here? Well, you can think about that for a minute. Why would I not just use this 150 Newton? That's the question. All right. So, what are we trying to do? So we'll park the force for a minute, and then we'll look at the velocity. Because we don't have any velocity information, we need to look at the sum of the forces in the x is mass times acceleration in the x, sum of the forces in the y, mass times acceleration in the y. What are we trying to do? We're trying to find the velocity that the crate is moving at. And how are we going to do it? We're going to use equations of motion, and we want to solve for the acceleration in the x direction. Why? Because once we have the acceleration, then we can either integrate if it's not constant, or we can use the constant acceleration equations to find our velocity. Okay? So that's exactly what we do. We draw our free body diagram, and we calculate the sum of the forces in the y and the x, okay? And we calculate our acceleration. And notice that it's constant. Okay? It's constant. So that means in order to calculate the velocity, because we're looking for F dot V, to calculate the velocity, we use our constant acceleration equation with time equals 4 seconds. A goes in there, time goes in there, and we find our velocity. Okay? After 4 seconds, the crate is moving with a velocity of 0.312. Okay, so now we've got our velocity. We know that it's acting in this x direction. So I was just trying to get you to think earlier. If I just say 150 times, if I just put in, say, 150 here, because that's the force that the man applies there, times 0.312. Why is this wrong? Why is this wrong? Because this 150 is not the component of the force in the direction of the velocity. Remember, it's F dot V. So we need the component of the force in the direction of the velocity. So that is why we would have Fx times V, which is 150 times 4 over 5. Now we've got our component of his force in the x direction times the velocity. And there we have the answer. Okay? Alright. Hope you didn't get too confused. Hope it's making sense.